All right, hello again, everybody. Welcome to today's geometry lesson. On 10.3, we're continuing with circles. We're going to talk about some arc and chord properties in this section. 4 properties that you can use to do some more types of problems that involve arc and chord measures and lengths. We're going to go ahead and discuss the 4 properties, or look at them and illustrate them on the front side, and we'll do a couple example problems on the back side. Remember that most of these are, pretty straightforward. Again, most things in geometry are how they look. Not always, there are exceptions. So most of these properties should look like they make sense. They should be pretty straightforward to understand. So let's get to it. All right, the first one at the top. We start with congruent chords. So let's say we have 2 chords, which are segments, 2 chords that are congruent. We know that. Well, if we have those 2 chords that we know are congruent, then it follows that the arcs also made are congruent. So that would mean if these are congruent, then arc AB and arc XY are also congruent. So if you have congruent chords, then you have congruent arcs. And remember, the way you name or write an arc are the endpoints with the arc symbol. That would be a congruent arc to XY. Now this property also works in reverse, or the other way around, or the converse. So if you knew the arcs were congruent, then the chords would also be congruent. So remember, this is like an if and only if. It works conditional and converse, forwards and backwards. Okay, second property. Okay, this one says if you have a radius and it's perpendicular to a chord. So here you have a chord, and this radius coming out of the center is perpendicular. You get a 90-degree box here. Then it follows that it chops this chord in half. It bisects this chord. So each of these halves would be congruent. Okay, if you have this radius coming out of the center, and you know that it hits at 90, then it has to go through the very center of this chord. So it bisects it. Now over here I drew a non-example, so you can see what it might look like if it doesn't follow this. So I purposely drew this one so that you can tell that it does not hit at 90. So obviously if it does not hit at 90, it does not go through the center, and you can see obviously that it would not bisect it. So this is like a fail over here, I guess. So if it hits at 90, if the radius hits at 90, it's got to go through the center, it bisects it. If it doesn't hit at 90, obviously it does not create 2 congruent halves, it does not bisect, it does not go through the center of the chord. Alright? Next property. Now this one says if you have a perpendicular bisector of a chord. Now this chord right here, I drew a longer vertical segment. It does not follow this. Okay? It might be perpendicular, but you can tell it doesn't bisect it. So think about where we would have to move this vertical chord for it to go to the center of this horizontal chord. It would have to go through the center, right? It would have to be the diameter. So if we were to have a perpendicular bisector of a chord, then it must go through the center. So just think about where you would have to move this for it to not only hit at 90, which it looks like it probably does, but to also go to the center. It's going to have to go to the center of the circle. So if we were to move this so that it did hit at 90 and the halves were congruent, so it's both of these, perpendicular and bisector, then it would have to go to the center. Because if you moved it off of the center, it would not do both of these. Okay? And the last property. Now on this one, here's what you have. You have two chords, here and here, two chords. And what you have is you have them being the same distance from the center. Now, the reason you know they're the same distance from the center is because these two segments are congruent. Okay, so these two segments being congruent means they're the same distance from the center. So if you have a picture or diagram like that, where this if part holds, then it follows that the chords must be congruent to each other. So this chord is the same length as this chord. It has to be if they're the same distance from the center, meaning these two are congruent. So let's say this chord was 10, a length of 10, this one would also have to be a length of 10. Okay? Alright guys, those are the 4 properties from this section that they want us to look at. So we're going to go ahead and use them to do some problems. Let's go ahead and go to the back. Or page 2 rather. The first 2 problems aren't terribly difficult, but just understand how you're using one of the 4 properties in order to do the problem. So we look at number 1. We need to solve for x or find x. Now we're given 2 70-degree arcs. And from the first property on the front side, we know that if the arcs are congruent, then the chords, the segments are also congruent. So therefore, since we know these are both 70, we know these 2 segments are equal or congruent. So we can simply set them equal to each other and solve for x algebraically. So solving, we have 2x equals 22, and x comes out to be 11. Now guys, if you did not know one of these arc measures, you cannot solve for x here. Because if you don't know the arcs are equal, then you don't know that the chords in turn are equal. So you couldn't do this problem unless you knew both the arcs were the same. All right, let's do number 2. Okay, on this one we're given that the two chords, these two segments, the chords are congruent. That means the arcs are congruent. Now, this one, there's a little overlap area, but that overlap area pretty much cancels out. So that means the arc part remaining, these are congruent. So again, we can set them equal because we know this. All right, so 80 degrees, or 80, is equal to 4x plus 14. Solving for x. Divided by 4 here gives us 16.5 or 16.5. All right, there's number 2. All right, let's look at number 3. Now, number 3 I modeled after one of your homework problems from the book or from this section of the book. Number 3, if you want to make a little note, number 20 in your homework, it involves, I think, a skateboarder and a skate ramp, something along those lines. All right, so let's see what number 3 is giving us here. All right, it tells us, it gives us a diagram. This is the radius or diameter, so this is coming from the center, it's the radius or diameter. And this is part of a circle, so we're given part of a circle. All right, it says if arc XYZ is 27% of a complete circle, then what is the measure of arc XY? Okay? Now remember, measure is different from length. So if they want the measure, measures in degrees. So we want the degree measure of arc XY. Now, if this is coming out of the center, if it's the radius or diameter coming out of the center, it's going to chop these in half. So that means this arc and this arc are congruent. All right, so XY is half of this entire arc. A couple different ways you can do this. Since we know it's 27% of a circle, we can find 27% of a full circle, 360 degrees. So change this to a decimal, multiply by 360 degrees. And that is 97.2 degrees. And now since we know that XY is half, we can just take the 97.2 degrees, divide it by 2, and you get 48.6 degrees, which is the measure of arc XY. Again, that's similar to number 20 in your homework. And there we have it. Examples 1, 2, and 3 in the notes. All right, guys, that's it for today. You guys stay safe and healthy, and I'll see you next time.